What are widgets, elements, and render objects? My name is Norbert Kozsir. I come from Germany. I've been developing with Flutter for about 2 years now. And thank you all so much for being here this early for a RenderObjects talk. So let's start off. Why care? And I'm here to tell you, for the most part, you don't actually have to care that much. Flutter does an excellent job abstracting all those details away and providing a nice and easy to use widgets layer to build performance and easy to build Flutter apps. But there are still a few reasons why you might care. For example, performance. Everybody loves to have those 60 frames per second. Understanding how the actual rendering is happening, what render objects are doing under the hood, might help pinpoint down those bugs and reduce those bottlenecks. Also, sometimes you just have a really custom design, which is quite hard to implement using just widgets. You might have run into that where you did some weird tags. That might actually benefit from a render object or something similar. And last but not least, just understanding how the framework works makes you understand the bigger picture and makes it easier to integrate into the framework. So let's start off with a few examples. Probably all yous have seen this, a pretty standard stateless widget. A stateless widget only composes different widgets. We use this all the time, but there are things which are widgets, but are not actually widgets. So let's take a look at the first example, the checkbox. Probably most of you have seen this or even used this. Checkbox, if you look at the slow motion animation, is actually a pretty complex widget. Like if you tap on it, you have the border animating, you have the check which comes in and does all sorts of things. And implementing this using widgets might be pretty difficult. Like you might try to use some sort of container, animate the border, use a custom pane to draw something. But then that can get pretty difficult. So if we take a look at the internal checkbox, so the checkbox itself is a stateful widget, if I recall, but the checkbox which actually renders is a leaf render object widget. That means it is at the leaf of the tree. It has no children, it just paints. In there it has direct access to the canvas, it has access to sizes, to layering information, and can do custom stuff very well. Next example, list tile. List tile is actually also implemented on the render object layer because the list tile spec is actually pretty complex. So this is just a very small screenshot from the spec from the material team. As you can see, they have very specific sizings and paddings. And implementing all of those, like it would totally be possible using rows and columns, but just having all those corner cases might be difficult. Last but not least, an example of elements. Remy uses them in a few projects. Hooks, if anybody has heard about it, it basically allows to store information inside the element, meaning you can write code like this where you use an animation controller inside the build method. Also, he told me provider internally is also using a custom element to do some fun stuff. As you can see here, it extends a stateful element. But yeah, before diving into that, let's take a quick look at layers. Layers are a pretty important concept in computer science in general, and are also pretty important in Flutter. Flutter makes a great use of those layers and abstracts and builds on top of each layer gradually. You may have seen diagrams like these, maybe with more layers, maybe with less, but I think for this talk, this diagram is pretty good. At the very bottom, we have C++, the engine. Engine, basically, for the rendering part, interfaces with Skia, which is the rendering engine, which also powers Chrome. And all it does, basically, is send operations to the GPU and does all the heavy lifting. Next up, we have the first layer, which is actually implemented in Dart. So it is accessible in Flutter, that is Dart UI. What Dart UI is, it's like a thin wrapper around the engine. It exposes the things the engine can do to Flutter. So you have picture recorders there, you have a canvas where you can draw a line. All these things later get sent to the GPU and it does its thing. On top of that, we have the rendering layer. That's the first layer which actually abstracts away logic, layouting, and the whole pipelining. It takes care of making Flutter like it is. And of course, on top of that, we have our widgets, the material and Cupertino layer, which is a layer which uses widgets to provide other widgets. So let's take a look at a very simple app and implement it in all of those 3 layers. The app is very spectacular. It is a centered text on a black background. That's it. It's that simple because implementing that on the Dart UI layer is actually a lot of work. No. Yes, the Dart UI layer. Don't worry, you don't have to read the code. It just is a reference of how much code it is to get this simple example running. Let's take a quick look. First, we have the main method. The main method is the entry point to every Dart program. There we schedule a frame and set the callback what happens if we call that. Weird. Then, when in the callback, we specify some physical bounds. We instantiate a picture recorder, which basically records the commands we want to do to the canvas. So we don't actually draw on the CPU, but we buffer those commands and send it back to the GPU layer. Using that, we create a canvas. We use the canvas to draw things. Notice how we have to manually calculate stuff. And at the very end, we end the recording, we build the scene, and send it off to render. It was a lot of work, so let's see what we can do better. The RenderObjects layer. Same app, a lot less code. If you can see, it already looks a bit more like Flutter. You have this tree where you have, instead of widgets, RenderObjects, and you have them nested with data. So, it's a lot less code, it's also very declarative, like you can see what the app is doing. But how does this work? How do we get from a render object back to those UI operations? For that, let's take a quick look at the rendering Flutter binding, which was the very topmost render object in this example. In there, let's take a look at the rendering binding. Basically, there's a lot of mixins which do a lot of bindings, but that's not important for now. In there, we have a pipeline owner, which is basically an object which takes care of the pipeline. It has all the dependencies, it does all the scheduling. Next, we have our window, which we used before too. And then we have a persistent frame callback, which is called when we produce a new frame. In there, most important thing is we draw a frame. Inside the draw frame, it illustrates very nicely how the pipeline actually works. So, first off, we layout. After we have layouted, we composite. Composition, just very basically, Flutter uses layers. And a layer basically is, you can imagine as a layer in Photoshop. You can draw to a layer, and without having to redraw the layer, for example, position the layer somewhere else, blend it with another layer, and yes. There's an excellent talk on the layers on YouTube. If anybody's interested, you'll probably find it. After that, we paint, where we actually make those commands to the canvas. And next off, we just send it off to the GPU and let it do a thing. The box layout model. Let's take a quick look at one of the most important things. The render objects, the layouting. So that was the very first phase in the pipeline. Before mentioning that, I just want to show Flutter documentation is great. Like, no joke, there's a lot of text in there, but if anybody's interested, without this documentation, it wouldn't be nearly as easy to understand what's going on. I sped through this like a 4x. It's just so much, and you really understand why they're doing it and how they're doing it. But yeah, so let's take a quick look of what we have to do in the layout function, what happens in there. So in this case, let's see what this example perform layout is doing. First, check if the child is null, and if it is null, we set our size to 0. So that is our first responsibility. We have to set our own size during the layout. Next off, we have to lay out all our children. So for example, this is a single child render object, meaning we have one child. So we do child.layout, and we have to pass constraints. Constraints That's the contract. We get constraints from our parent, and we pass constraints to our child. A constraints object basically is an object which specifies what is the minimum width and height, and what is the maximum width and height. In this case, we loosen those constraints, meaning remove the minimum. Then we also say we use the size of the child to make the framework rebuild ourselves. Next off, setting the size, as we had to do. And at the very end, we save the data. Important here is this data is saved inside the child. So whenever we want to have data which is associated with a child, we use a so-called parent data. And in there, we can do all sorts of things. More on that later. But that is the general overview of what a render object does in a layout method. Painting is a bit simpler in this case. If we have a child, we get those parent data back where we stored the data where we want to position it, the offset, and we just call context.paintChild, and it does a thing. We can do anything in there. Like the context is a canvas, we can draw lines, we can draw rectangles, we can push a new layer which adds an opacity. We have full control over there. So, very quick recap. What have we taken a look at? Dart UI, a thin wrapper around the engine, and it basically has a canvas where we can draw to. Drawing to the canvas means recording those commands and sending it off to the GPU later. So it's very low level and very tedious. Next off, we took at RenderObjects. RenderObjects abstract away the need of having to manually calculate sizes, widths, positions, and adds a protocol for a child-parent relationship where you can have a layout model where we pass constraints, set our own size, just have the whole system take care of that. So, why don't we just use RenderObjects directly? Why do we need widgets? So consider the following example. We have a render transform. The thing we want to do is we want to spin a square. Child square is some sort of square. If we now want to spin that, we cannot actually rebuild the render object tree. What we have to do is we have an animation controller here with a listener. And in there we have to manually keep a reference to that child and update the transform by ourselves. Because render objects are very heavy, like they have a lot of cache values, they have a lot of references. We don't want to rebuild them every frame. So, that's where we get to the widget layer. The widget layer solves this problem by providing a reactive API. Just as a reference, you probably all know this, but this is the same app which we looked at, written in the widgets layer. Just one line of code, like it is a really high abstraction, but we can clearly tell what's going on. We have a center, and in there we have a text with hello world. So, what are our goals for the widgets layer? What do we want it to provide on top of render objects? So, first off, we want it to be reactive. Instead of having to keep references and manually updating things, we want to rebuild the tree and just magically have it update anything that we have it updated. So what is the problem? As I mentioned before, render objects are heavy. We don't want to rebuild those. So a possible solution, which Flutter is actually using, are small container objects, which we conveniently call widgets. Widgets are very lightweight, and therefore the Dart VM, or Dart itself, can allocate a lot of those small objects for a relatively small cost. Widgets only have data in them. They don't have references to our widgets. They have no references to render objects, elements, or whatever. They're only objects containing data. So, now we need to somehow connect those two worlds. We have those small container objects, which have no references, which have no meaning. They don't have any layout functionality. And we have render objects. Render objects also have data, but they have all the logic. They have the references. They have a reference to the pipeline owner, and they can actually draw stuff. So therefore, we need another tree, which is the element tree. The element tree basically is the glue between render objects and widgets, which we so much need. You can think of as render object as being this persistent thing we don't want to throw away, and widgets being these things we want to throw away all the time. And elements being also persistent, but having a reference to both of those and managing both. So let's take a quick look at how an app might take those widgets and convert those to the render objects, which later produce all those commands we need. Consider this example where we have a center and a checkbox which is checked. First off, the center is asked, because it is the topmost widget, to create an element. In this case, the element is a single child render object element. Names are pretty long, but it's pretty clear what it is. It is a single child because it has only one child. Remember, you cannot put multiple children in the center. You can put none in there, but that's okay for the single child. It is a render object element, meaning it is an element which actually has a render object. Some elements don't have a render object. For example, stateless element and stateful elements. What are they drawing? They're not drawing anything on their own. They're just using the thing that is returned. They're drawing that. Next off, it is, Here you can see where the create element is called, just as a bit of context. Next off, the element is asked to create a render object. In this case, the center produces a render position box. That basically is a superclass which also manages stuff like align and other things, and center is also using that. So, because we know the single child render object has exactly one child, it has a reference to that one child, and it asks, before going to there you can see how the render object is created. It is inside the mount method, which is basically called the very beginning. Yes, as I told, it has one child, so it has a reference to that child, and it can ask the child to inflate itself to an element. In this case, the checkbox inflates a leaf render object element because it has no children, it only paints stuff. It does this also in the mount method, which is overwritten by a subclass, and there it calls the update child. If you take a look at the documentation, update child is actually a very important method, which also has a lot of documentation. And things are implemented such as looking if the key is the same or different. For example, if we rebuild the widget tree with a different key, it cannot reuse the element, so it has to throw away the element and re-inflate it. But more on that in just a second. And then it creates a render object, a checkbox render object widget. Now we have the render object tree. Using this render object tree, we can kick off the pipeline with a pipeline owner. It can then layout, it can then composite, it can then paint, which calls all those callbacks inside those render objects, which add their commands to that picture recorder, which you took a look at the very most bottom layer. So, a quick side note, build context. Build context can be found pretty much everywhere. And I'm pretty sure some people have asked themselves, well, what actually is the build context? Why do I need it? You can use the build context to look up parents. You can use the build context to look up a render object with a size if you have already built. So the magic behind the build context is nothing more than an element. Element actually implements build context. And whenever you have a build context, you're pretty safe to cast it to an element and use all things in there. That's why, using the build context, you have access to the render object, because the element does. Because remember, it is the glue between those two worlds. Here, the stateless widget, it is actually a pretty small class, and the build method, which is in the middle, there it calls widget.build, which is the method we all implement daily, and calls it with itself. Meaning, in a stateless widget, the build context is a stateless element. So, let's take a look at the diagram. What happens if we rebuild the tree? Maybe we run app again, maybe use set state or something. So what we do first, we throw away our old widget tree, which you can see visualized at the top left, and we replace it with a completely new tree, which has nothing to do with the old tree. Like, they're completely new allocated objects, which also is a center and a checkbox, but this time the checkbox is unchecked. So all we changed is the data in there. So what happens is we do the same. We update, but instead of re-inflating a new element, it actually connects back to the same element because it sees it's the same runtime type. It doesn't have different keys, so we can just reuse it. Same for checkbox. same runtime type, no different keys, so we can reuse it, but this time we see some data changed. So inside the render object, we call did update render object, and we set the new property, which then kicks off a new frame and drawing and maybe layouting again. So, quick recap again. Dart.UI, low level, picture recorder, we draw stuff to a canvas. Render objects, we have some sort of protocol of how to draw. We have constraints, we have size, we have children. We can do all those things, but we don't have the reactiveness. Like, we cannot rebuild the tree, which we are all used to and which we all love. And widgets solve that by adding another layer, also having elements which connect those two, which do the logic of connecting widgets to the corresponding render objects and updating those. So, a lot of theory. Let's try to build a render object of our own. So, what is the render object going to be? It's going to be a center from scratch. We already have a center widget like that, what I said at the beginning. Like most widgets are already implemented, but maybe some use cases have some things which aren't. So let's see how we can rebuild center. Before taking a look at that, let's see the specs. What does the center, what should it be? So first off, if we have no child in the center, we want it to be as small as possible. We don't want it to occupy any space, we want it to be just gone. It doesn't do anything, it cannot center anything. Next off, when there is a child, we want to take up all the space, which is indicated by the reddish color there. And inside that space which is taken up, it should center the widget in there. So, let's do a bit of live coding. So, first, instead of creating a status or stateful widget, we create something else. We call our class myCenter because it's the most creative name I can come up with. And we extend single child render object widget. Yes, names are sometimes annoying to type, but widget, yes. It's quite hard to type because I only see this with a small delay. But yeah, so we have to implement the method, so we have to first import. And yes, so we have to implement the method create render object. So this method has to create the actual render object. Before we do that, we want to take some parameters. First off, myCenter takes a key because we're good citizens and every widget should take a key. So we take a key and we take a child. Notice how we don't save the child in ourselves because the single child render objects take care of it for us. So we just pass the key, we pass the child, space. So let's implement, remove some white space, implement the render object. So the render object, let's call it render myCenter, which is actually a pretty fun name. We extend render box. In here, we have to mix in a render box with, it was render object, with child mixin. We have to use that because the single child render object widget, which creates a single child render object element, expects us to have this. This layer is not that intuitive most of the time, so when you're doing something on that layer, I recommend just taking a look at examples of things that are similar. So in this case, I actually took a look at the center, which had like 5 superclasses, and I took a look at what things had to be implemented, and then you can build something. So in here, as you can see, we don't actually have to override any methods, but we want to override it. Before doing that, let's just return this in here, return render myCenter, and we have created a render object. So in here, we want to override the perform layout. The perform layout is the thing where, well, we perform the layout. You may notice this is pretty similar to the example we looked before. It is not exactly the same, but it's pretty similar. So first off, if we don't have a child, we want to be as small as possible. So let's see, child, if it's not null, we want to do our logic. Else, we want to do size equals 0, smallest size possible. So let's see, what do we want to do? We have to first lay out the child. So we do child.layout, and we need to pass in some constraints. As you can see, we get the constraints from our parent. So we have a max size, but we want to allow the child to be small. Like there could be a widget which is very small. We want to still be able to center it. Therefore, we can just loosen these. Just taking a quick look. Can I go in there? Yes, I loosen. All it does is removing the min width and min height. And also we need to pass parent user size, because we as a parent in our little algorithm going to use the size in just a second. This is for Flutter to know that when the widget changes, we have to actually also change the parent, because imagine we have a widget which is wide. If we shrink it now, we have to recenter it because it's not in the same position. Next off, what do we want to do? We want to calculate the middle. So there's this little formula, which is actually, if you draw it, pretty simple. But in the x direction, we use our own width, max width, and subtract the child dot size. What was it again? It should be, yes, I had this before. Don't forget to add a generic parameter, because else it will not give you the size option. It's a render box you want to have here. Like these things, don't memorize them. Just take a look at examples, because these are a lot of those things. So now we have access to the size, and we can do width. So if we divide that by 2, we actually get the correct position. I have a graphic which I might show later, but if you draw it, it's pretty intuitive how to calculate this. But that's not important for this thing. So we do the same thing. Let's just copy this and replace this with the y. Let's use the max height and the height here. So now it comes to storing that information. We store the information here because it might happen that we want to redraw this widget without actually having to relay out. Therefore, we store that in the parent data. In this case, it's the box parent data, parent data, child parent data, and it's child.parent data. And in there, we can just do child parent data dot offset equals offset dx and dy. So that's pretty much it. That's our perform layout method. Nothing will happen here because we haven't actually painted yet. So let's implement the paint method. Let's go down here. Maybe remove some white space so you can see both. Nice. So, paint. In there, we have a painting context and an offset. So the offset is like, in the render objects, we can paint anywhere we want. We can theoretically paint outside of our bounds, but as the contract says, we're not supposed to do that. The offset says what offset on the global canvas our widgets starts at. So we always have to add that on. So in here we do if child doesn't equal null, we paint it using context.paintChild, and we use the child, and in here we use the offset, which is center gets, and add the parent data, which we can get by parent data is child.parent data as box parent data. We have to cast it, and then we can access the parent data dot offset. So that's pretty much it. That's our render object. One important thing's missing here, which I don't want to implement right now, because it's just this little boilerplate code here, is hit testing. because we transformed our child into the middle, we have to also transform the hit test. Like, just using this code, the child hit position would actually be at the top left. So we'd have to implement that, but that's not so important. So if we go to the R file I've prepared, and so this is just a basic app, which I can run on desktop, which should just take a second. It's very fast. So what you'll see is just the basic scaffold with the app bar and a text in the top left because we haven't centered it yet. But we're gonna do this just in a second. I want you to believe me that it's actually our render object which does it. So there we are. That's quite big. So we have a high at the top left. And if we wrap this in a my center, which I've already imported, and hot reload, there's an exception. I did one little thing wrong, I'm not quite sure what, but it is centered. So I don't want to do... So I don't want to do the live debugging now, that's for another talk. But yes, so these are just the, if the live coding wouldn't have worked. So that's actually how it's supposed to, oh yes, I'm supposed to use the size directly. Yes, size, yeah, of course, okay, we can fix this really fast. I missed the most important thing. The render object has to set its own size. Right now we only set the own size when we don't have a child. So what we do at the very beginning, what we can do, is we want to be size constraints biggest. We want to be as big as possible because we have a child. So now if we hot reload, no errors and it's still centered. Yay. So before I finish this talk and we go into a little Q&A session, I want to do a quick plug of a project that I've been working on with a friend. So we've been working on this for a bit, and the idea is what we're going to do is provide high-quality Flutter assets, UI assets, which also go a bit deeper and focus on quality. Like we want to do some custom render objects and things, and eventually trying to solve the problem that a lot of open source projects are built by people in their free time. They don't get compensated, and it's hard to maintain and keep that up. So that's a vision we're working towards. If you're interested, I'll be here for 2 days. Just talk to me. We have a nice landing page set up. It's framecrate.io. Thank you. So, does anybody have questions? Sorry? The paint method, of course. This one? Yes? Or?
I have a question.
Yes.
Regarding this plugin to the Android Studio, this Nyan Cat, what is the name of this plugin?
I think it's just called Nyan Cat progress bars.
Okay, thank you.
Basically replaces every progress bar there is with Nyan Cats, which can be pretty fun. Sorry? Ask IntelliJ, guys. Any other questions? Yes. Yes, so the question was, why does the center, for example, store its information in the child, not directly inside itself? So there are multiple reasons. For example, there are elements and widgets, for example, list views, who do lazy building and stuff. And storing that in a child is just more convenient because it's always up to date to the child. It corresponds to the child, and you don't have to manually keep track where the data is, which indexes is, whether it's still fresh or you should reset it. So in this case, you just store it inside the child, and there's actually a method, which in this case we don't have to override because we're not using a custom parent data, what's called setup parent data, and all it does is set the parent data of the child to a new empty parent data of that type. So in this case, every time we have a new child, the setup parent data is called with the box parent data, which just sets the offset to 0 back. Yes, you can definitely break Flutter. And first rule is try not to use render objects. Like render objects are very powerful, but most of the time you don't actually need them. Like most of the time there's a way to do this with widgets. There's also the custom paint, which may be for a few occasions. There's a custom multi-child layout, which can do multi-child layouts. But sometimes you just need to have something very custom. For example, you want to have some sort of a list view, which does some very new caching and whatever, and you want to have full control over what you're doing. Then you need custom element, custom render object, or for example, if you want to squeeze out the last bit of performance because you want to have some calls optimized. But definitely, like breaking stuff on a render object layer is super easy. As you have seen, I forgot to set the size, which is nowhere like on the widgets you see, okay, you got the constraints, this is not allowed, fix this. Render objects like, something went wrong, fix it. But yeah, like if it feels awkward to implement on widgets, like if you're using a lot of post-frame callbacks and layout builders and a lot of those things, you might consider using render objects because in there you also have access to the size, to the constraints. Like you could do, for example, if my available space is bigger than my child wants to layout at, or something like that, you could do that in there. Yeah. Did it answer the question? Yeah.
Can we go back a little bit to the checkbox example? You mentioned that when we recreate the widget tree,
yeah,
the elements get relinked to the new widgets. So let's
yes.
imagine that we have not a center, but some other component, some other widget that can actually have multiple children. And for example, imagine that we are creating a second checkbox when the view gets recreated. So how does the Flutter decide which checkbox gets linked to your existing element?
Yes, so you're talking about list views where two children, you may be removing one?
No, let's imagine that we have some more complex element, and for example, we would like to add another one.
Yeah.
And how does the Flutter decide which widget will be linked to the existing element and which one will be inflated as a new one?
So there's two main criteria for this. First one is the runtime type. The runtime type is different. Obvious, you cannot relink them. Like if you replace a checkbox with a text, it doesn't match. Next off, there's this key. And that's also the reason why in list views and stuff, if you animate those and remove stuff, you're supposed to use keys. Because if you remove an element, it tries to relink the element because it is the same runtime type with different data, and it breaks the animation because instead of recreating and animating, it relinks those. So yeah, mostly runtime type and keys. If it is the same runtime type and it doesn't have different keys, it relinks them, mostly. Like, maybe there are some more, but that's the core of the algorithm.
Over here to your left. Hi. So in terms of performance and when to use custom render objects, for instance, in the early days of iOS, it was very common to do your own custom drawing because compositing was had bad performance. At which point do you think that you should consider doing custom renders where compositing widgets will take a performance hit?
So in this example here, most of the time, Flutter actually does this optimization for you. As you can see in this example, it doesn't have to do much. It updates the data. Meaning if you rebuild the widget, it says, okay, same runtime type, same key, and it calls did update widget. Did update widget basically just sets each property. And in RenderObjects, your setter is supposed to be an actual setter, which sets the value and then marks itself as needing to repaint, as marks itself needing to layout or composite. So most RenderObjects already have this optimization in place. For example, I think if you uncheck a checkbox, you don't have to re-layout it. It only marks itself as needing to repaint. Sometimes widgets don't do this. Maybe you're using a stack or something. Like, not 100% sure, but I think a stack, if you update the position, it actually re-layouts, which you may not want. Not totally sure about that, but those might be some corner cases where it might be interesting to look at the render object. What is it actually doing if I update this property? Is it relayouting, recompositing, repainting, and what do I need?
So, but in general, just using plain old widgets and animation controllers, etc.
Totally.
It should be totally fine.
Totally, yeah.
Thank you.
Any other questions? There.
Hi. Just one question. Before, in the layer, you described everything start with the Skia graphics engine, right?
Yes.
So, can we start use drawing just with that, with the dot for FFI library is the right foreign function interface? So before, just like, have you tried to use that before reaching up to the render objects? Try to draw using the direct Skia rendering APIs.
Well,
is it possible? Just
I mean, of course, you could, like FFI, you have code which you can call, you can embed some sort of OpenGL context and write your own wrapper, but you'd have to re-implement basically the engine. That's what the engine is doing. It creates your context, it creates the window, it gives you some context to paint on and exposes the methods which it needs to paint on a context for you.
Okay, thank you.
Hello. I have a question. There is a big difference between the usual Flutter elements and render objects and Sliver
Yes.
render objects and elements?
So the box protocol is one protocol I mentioned here. There's also the Sliver protocol, which is a different protocol which is implemented in the render object. And those do something different. They don't just pass constraints and do all that stuff. They have things like remaining paint size and whatever, and they have a whole other layout protocol you have to conform to implement a RenderSliver. So every time you see a RenderSliver, that's how they mostly name those. Those are actually conforming to the Sliver protocol, which is different to the one I showed here. Fair, it is more complicated and it's like confusing at times. Like.
Okay, thank you.
Any more questions? Okay, then thank you all for being here. I hope you have a great stay here in Warsaw. If there's any more questions, feel free to approach me. I'm happy to answer the best I can.